Okay, welcome everyone. My name is Maciej, and this is Phil, and the both of us are leading the SIG CLI. So today, I'll spend a couple minutes introducing our SIG, what we do, what we are, our mission in short, and then I'll jump right into the core parts of the kubectl, meaning how to develop a simple kubectl plugin command, or basically fix a bug so that people such as you who might be interested in contributing to the kubectl can benefit from that knowledge. I do hope that this will help you get started. If you have any questions at any point in time, either post-conference, I'll leave the contact details. You can reach me out on Slack, same for Phil, Twitter, and whatnot. Basically, these two handles work throughout Slack, GitHub, Twitter, and whatnot. So what we do, so in general, we build kubectl. What is kubectl? kubectl is the main Kubernetes CLI. So it's a client for interacting with your Kubernetes cluster. Of course, there are a couple additional features that we developed over time, such as the CLI runtime, which is a set of helper methods for building kubectl commands or plugins if you're interested in doing so. What is important is that the CLI runtime, its first and primary consumer is kubectl, which guarantees that it will always work. The additional tools that we adopted over the past 6 months to 12 months is Crew, which is a plugin manager. If you've seen our talk with Ahmed 2 hours ago, we covered the tool. It's basically a plugin by itself, but it allows you to manage and install plugins for your environment. And finally, Customize, that was added to kubectl about 9 months ago, is a tool for declarative workflows, for improving declarative workflows. Think about apply on steroids with some additional tweaks that you want to add on top of your current yums. It definitely improves working with very cumbersome yums. So like I mentioned, our structure is very simple. We have 2 tech leads. Both of them are standing in front of you. That's myself and Phil. I'm representing Red Hat. Phil is representing Google. And we are responsible for the technical leadership in our SIG, which basically means we are deciding about the goals for the next couple of months, years, where the SIG will be driving, and we are ensuring that we keep the track as is. Whereas with Sean Sullivan, myself and Sean, we are responsible for organizing the SIG on a daily basis. That means running the meetings, keeping the notes, putting the recordings of all our meetings into the YouTube channel so that you can view them afterwards if you're interested in what happened, as well as keeping the notes. I'm not sure if I linked the notes. What are the couple main initiatives that we are working on? So one that you probably have noticed if you're active in the kubectl area is that we are moving outside of the main repo. Some of you probably stumbled upon Kubernetes/kubectl repository, which exists for a good couple years. But the main problem of that repository is that it does not contain the kubectl logic nor the binary. And it is confusing, even though that some parts of the kubectl related code exist there, like the book, which is the documentation parts we published in the last release, thanks to awesome work from Phil and his team, which is the kubectl book, if you heard about that one. That one lives currently in the kubectl repo. The rest of the contents is not being maintained in any significant way. And actually, Sean sent out an email earlier today, or that was maybe yesterday, announcing that we will be pruning the contents of that repo, and all the important bits like the book that I mentioned will be moved over to the main repo temporarily for us to be able to extract that contents to the kubectl repo within the next couple of weeks, months. Initially, we will be syncing the contents out to the repo, and hopefully within a year, 2 years from now, we will be fully outside of the main Kubernetes repo. There are a lot of efforts and mostly challenges around how to test properly kubectl against Kubernetes cluster, how to test kubectl itself internally, and most importantly, how to ensure backward and forward compatibility that we currently have, which is at the time ±1 version. Also, we are moving quite a lot of functionality over to the server. One of the major refactors that we did in that area in the past months were server-side printing. So meaning if you invoke kubectl get command, the description of the resources that you see in your CLI are not actually hard-coded into the kubectl itself anymore, but rather they are coming from the server. This ensures that any consumer of the API can have consistent output. A lot of effort has been recently put into moving the kubectl apply over to the server. There is an alpha functionality these days that allows to apply single resource currently, but there's a lot of effort to improve both the server side and the client side apply. There are a couple others, like I mentioned, the plugins, and there's a lot of work around customize. So these are ongoing projects. If you're interested, I completely am more than happy to see you all on our bi-weekly meetings. Our regular meeting would be scheduled for tomorrow, but due to KubeCon, we obviously canceled that one. So the next one will be in 2 weeks. These are held at 6 p.m. I didn't put that one, but it's basically 6 p.m., not a.m. European time. It's noon for the U.S. Eastern time and 9 a.m. for the Western time, U.S. Western. We have, obviously, our Slack channel where you can find both of us as well as Sean as other members of the SIG CLI, who will be more than happy to answer all your questions. If you have some PRs, reviews, issues, feel free to reach out to us. If you're afraid of asking this publicly, you can always reach out privately to either one of us, and we will be more than happy to answer your questions and help with your issues. If you're a first-time contributor, that will be more than I'll be more than happy to help you. And actually, we are thinking about putting together a mentoring group for people that are interested in contributing to kubectl. Of course, there's also Google group, so you can sign up on that one. So you'll see the information about what is currently in progress, what we are working on. It's very low volume. I would even say once, twice per week, there's an email. So it doesn't hurt. It won't flood your inbox in any way. So before we jump over to the kubectl code base tour, which I do hope will help you to get familiar with the code base, and I know that there's several people reach out to me asking just for that one, and I gave a similar tour about 2 weeks ago during one of the contributor meetings on YouTube. Do you have any questions at this point in time? Okay, so let's get into the tour. So the entry point for kubectl lives in Kubernetes command kubectl go, and as you probably have noticed, it's literally very minimal. We only create the command and pass over the entire functionality over to the Cobra command. Cobra is a CLI library created by, I can't remember his name, Federico. SPF13 is his GitHub handle, and I probably think most people will recognize by that. So SPF13/Cobra is how you find him and the library on GitHub. And basically, the majority of the Go-based code these days that is CLI-based will be using his library because it's pretty cool. So let's look into the new default kubectl command, what it does. It actually, aside from setting up the functionality and commands and flags, it registers a set of commands, all of the commands that you'll see, and I'll be showing you in a minute. We group the commands into several batches. So there are basic commands such as run and set. There are intermediate commands for getting, editing, and deleting resources. There's a set of deploy-related commands like rollout, scale, or autoscale. There's a set of cluster management commands such as top, cluster info, or cordon, uncordon nodes. There are troubleshooting and debugging commands such as attach, exec, proxy, or describe. And then finally, there's a set of advanced and settings commands such as annotate, completions, patch, apply. More or less, that I do hope that's reasonable. The grouping is not in any way hard-coded. We can always change that one if we see the need for it. So, but honestly, the majority of the code that I show you so far, you will be rarely touching. I can't remember touching any of those in the past 12 months or so because it rarely changes. Well, I lied, of course. I did change. When I was relocating commands, because previously we didn't have good code organization, I did change the previous file that I was showing. But honestly, it won't be changing that fast. So the main part and where actual commands live is inside of package kubectl command. And then inside of this directory, each and every single command will have its own directory, except for some few rare cases, such as API resources actually has two commands. One is API resources, and the other one is API versions. Both of these are very similar, and they share some functionality underneath it, so we decided to put both of them into the same directory. But other than that, the majority of the commands have their own directory, and I do hope that if you've at least once invoked any of the kubectl command, you'll recognize the names of the commands easily with just scrolling through the directory contents. And that will also allow you to easily navigate to the commands that you want to improve, fix, or break. That's also allowable in some ways. One important information is that the get command, although it seems to be the simplest and the first command that you can think of when you're working with kubectl, I must warn you that the kubectl get command is one of the most complicated of all the commands. Honestly, and I'm not lying, I'm not making up. There's a lot of code in the get command because there's sorting, there's support for the new server-side printing mechanism, as well as we still support the previous old mechanism if you pass -- server-side print false, which means the logic that was hard-coded in kubectl will fire in that place. And all that makes the get command not as easy as you might think. Also, there's support for watching, which is kubectl get -- watch. So the watch functionality is part of the get command. This all makes the get command grow very much. So if you want to start fixing, I would discourage you from touching get. It is complicated. Even for us current contributors, touching it, we are very cautious about modifying the get command. But the other commands are very simplistic. The API resources, annotate, they're usually very simple. And let me show you how the annotate command works. So if we go into the annotate directory before I jump actually into the actual annotate, there usually will be two files. Let's ignore the build file because this is automatically generated for the Bazel, which is one of the build process being used inside of our testing infrastructure. you'll probably see, this is the majority of cases, there will be two files. One will be the actual command, and the other one will be the unit test. Sorry, and the unit test for that file. So looking into the annotate command and omitting the import sections, there are a couple important factors, and we are trying to enforce this pattern across all of the commands these days. Not all of them follow these patterns, and get is one example of why we're not following. Get is one of the examples where we did not follow to the new patterns, and the reason is that it would cause more pain for us to rewrite it than just leave it as is. But overall, the rule is that we follow these patterns that I'll be talking about more. So every single command will have an option structure. The option structures will have a set of flags that the command exposes. You'll see that we are using something that is called print flags and resource printer. These two objects that are at the top are part of the CLI runtime that I mentioned before that we are maintaining and exposing so that other kubectl command writers, plugin authors can reuse. We are reusing the same inside of kubectl. These provide a set of flags, which is the first one, a set of flags for printing. So if you're passing -o, yum, or JSON or whatever, this exposes that functionality. So if you use the CLI runtime, this is what you get for free. And then the resource printer is the actual mechanism responsible for printing the resource based on the arguments that you specified before. So you don't have to handle those, because if you can, assuming that you're only writing in Go, because CLI runtime is as entire kubectl and Kubernetes written in Go. Other flags are for file name, for record, and the flags for actual annotate command, which is over at local var and whatever not. And then we usually put a set of helper arguments that we want to pass over from one invocation to the other invocation of command. Finally, there's IO streams, which is an object that is just holding all of the standard in, out, inner streams. So after we have the structure, I'm going to skip the information and description about the command, because I do hope it's pretty self-explanatory what it is. There will be a new command name or structure name, option structure, which will by default accept the IO streams object. And that method is responsible for providing the default values for all your flags that you are exposing as part of your command. In that particular case, we are setting up the print flags, the record flags, the recorder, and set the IO streams to whatever was passed. And now comes the actual command. The actual command will be always named new command and the name of the command. It can accept several parameters. We're not going to focus on them, but I hope that they are self-explanatory at this point in time. We create the new option structure that we just discussed, and then we put the information necessary for Cobra library to create a command. So we are setting the usage, short, long examples, all those information, and the main part is actually the run command. The run command tells the Cobra library how to execute our command. And in 99% cases, you'll see 3 invocations as part of that run command. And there will be always in that particular order: complete, validate, and run on run name of the command. And let me, I'll cover each and every single one of them in a minute. Then we bind the flags that we require for the command to work properly. And then we can actually jump over to the invocation of any single command. So the first method that is pretty much required for every single command is the complete. The complete is responsible for finishing the structure In our particular case, it's annotate options. So if you're invoking kubectl annotate, you're passing resource, name of the resource, eventual additional flags. Part of the complete invocation is to parse all the flags that were passed, as well as do initial client setup, setting up the printers, and invoking complete on print flags, for example, or recorder if there are. We are also creating the client here and necessary resources for the command to actually succeed. The next one, and that depends on your actual command. In our case, annotate option does have validate, and the validate, as you might probably expect from the name, is responsible for validating the structure. That is why having the structure is very important, because after complete, we need to have all the inputs inside of the structure, and then validate ensures that the structure is valid. And let me step back and explain why we decided to go with the structure and the three-method approach. Beforehand, it was very hard to unit test each and every single command. If it directly accepted std in, out, and std error, we were forced to either mimic those, or it was not easy to unit test each and every single command. That's why we figure out it's better to have a structure that you can inject whatever testing values that you want to have, and then just focus on the actual, either if you want to test validation, fine, test the validation, inject the values that you want to see in the structure, and verify whether it is working the way you expect it to work. If you want to test the actual execution of the method, the run command, you provide whatever flags as part of the option struct, and then you just run the run method and verify whether the output is the way you expected it to be. So after validation finishes, of course, at any point in time, if something fails, we return an error, which completes the execution of a command. And the run, as you might expect, is the actual logic of any command. So in the majority of cases, the run is the method that you will be touching the most frequently. Of course, run can invoke additional methods, and in our particular case, it's very simplistic. There's something that is called a resource builder that we created in the complete method. The resource builder is something that is part of the CLI runtime. The resource builder is a helper function responsible for reading resources from either a file or remote server. That's why we pass over the client to it, so that it knows whether it wants to talk to a client and how to reach it, or eventually a file name, because there is an option to pass a file name. And depending on how you pass the options, it will reach out and get the object that you requested. After we're done and we have the resource, we invoke a simple visitor pattern and visit each and every single object and then we apply annotation per user specification. So that's pretty much all, how each and every single command will look like. And finally, we are printing the resources, unless user explicitly asked us not to print it. Although I'm not sure if annotate has some questions. There are, of course, several helper methods. I'm not going to dive into those because it doesn't add any value at this point in time. So, as I mentioned before, we do test each and every single command, and there are 3 possible tests that can happen to overall kubectl. Next to every command, there will be always a unit test, and that is the simplest way to verify if the command functionality is executing properly. On top of that, there's a test command inside of Kubernetes repo, which is actually a set of bash scripts which are invoking kubectl commands against a sort of fake cluster API. Why am I calling this cluster API fake? Because we are setting only the etcd and the kube API server, and that's it. There's no kube there's no kubelet running, which basically means there will be no pods running behind it. So this is very simplistic, but it is sufficient to verify functionality of commands such as kubectl label or kubectl annotate, because they are working against a kube API server, and they don't need the kubelet part running. If you want to go all the way down to the kubelet running, so for example, you want to verify if kubectl logs is working properly, then you are reaching and talking about end-to-end tests, which are part of the test E2E. There's a kubectl subdirectory within which we have a Go, particularly that's Ginkgo and Omega based tests. There are invoking tests against a fully blown Kubernetes cluster. So for example, this one is creating cron jobs and then verifying the cron job is actually working or is being invoked the way we expected it to be. And there is a set of tests. I think that's pretty much the majority of the stuff that I wanted to show. What I would like to call out for you, if you are interested in working on SIG CLI, help us improve kubectl. We are very interested in changing the bash written test into a testing framework. SIG testing wrote an amazing framework that should help simplify the testing. And what is important also for us is that the test currently can only be executed on Mac or on Linux, basically anything that has a bash in it. Obviously, Windows does not have a bash, so we cannot execute those tests. We would like to see that on top of that, there's bash, so, bash is not always that good. For testing, it's definitely harder to work with bash rather than with Go. So if you're curious and happy about working on that part of the project, we'll be more than happy to accept PRs, slowly moving. I'm not saying that you have to sit in one shot, rewrite the entire thing. There's a lot tests in the test command package. So if you want to do it at once, I think that would be like 2 or 3 weeks of work, and then more than that to review that thing. So if you're interested, I would be more interested in having like file by file, or even up to the point where you are replacing part of the file with a new testing approach. I think that's the majority of the things that I wanted to cover. Phil, you want to add something? Okay, so does anyone have any questions?
Does this street test that you said gets invoked automatically when somebody sends a PR, or do you have to run it yourself?
So the question was whether we have the tests invoked on every single PR. Yes, all of the changes to Kubernetes repo and eventually to kubectl have a very broad set of tests that is being invoked as part of the test. This includes both the unit test, the test command, as well as the E2E tests. There are certain tests, certain groups of E2E tests that are very invasive. These are run as separate. Sometimes they are run only nightly, so once per night. But the all of the kubectl related tests are run on every single PR, so on every single push, actually.
Another question I have is, let's say I want to improve CLI and add some addition. And I only want to test my changes on CLI. I don't want to run all the tests. So is there any shortcut that something that shows?
Yes. So for running unit tests, the simplest way, let me try to find if I have, basically make test, and then and then you can pass package kubectl command annotate. That will run the unit test for that particular package. Similarly, you can run. Yes. Similarly, you can run test command, and then specifying what, and the what is actually, that's one probably a little bit more tricky. That's not the directory that I want to show you. So each and every single test in the test command follows this rule by naming. So there will be always run some underscore something underscore tests. And that something is the name that you should use to run that particular test. So if you would run this, that means only this function will be run. Of course, the setting up function is additional thing that has to be implemented. Thankfully, we have very good, I wanted make file. Thankfully, our make file has, oh, of course, that would be faster. So if you find test, we usually have a documentation above a particular target which explains what and how to run specific stuff. The same for test command, and what is a list of tests to run from these names. For E2Es, it's a little bit more complicated. But basically, it is similar to invoking Ginkgo command. So there's no makefile script for running particular tests. I have a script that sets up my local cluster using the local cluster up sh from Kubernetes repo and runs a particular test. The E2E test can be narrowed to only a single E2E, just passing the name of the test, which is usually let me find one that is actually, for example, kubectl client will run everything that is part of here, but that will be pretty big. So if you want to have, for example, simple pod, if you narrow that to only that simple pod, this is the only test that it will be running. Yeah?
I would like to have two questions about the plugins. Normally when you write a CRD, you just get this plain category, delete things, and back to it. However, there are parts of CRDs that say have a CRD for my new deployment, and I will just write something like scale instead. Is the plugin something that you put in this kind of, let's say, open code?
I can take that one.
Can you repeat the question also?
Thank you. Okay, so the question was, if you're writing CRDs, some commands such as git, describe, apply, these commands just work with the CRDs automatically, but there's other commands such as scale that do not.
Scale actually works.
Yeah, that's true. There's other commands that do not, and so what's the best way of implementing that logic? Should it be done through a plugin? So scale is actually done through a sub-resource now. You can specify on a CRD which field is the replica field, and then it will automatically make that work for you. But I think more generally the question is like, if it's not scale, if it's something else, what's the best way of adding that command? And I'd say right now we are looking at a way of publishing commands from the server and making them discoverable as forms effectively. So if you look at how web browsers work, they don't compile in all the websites in the world. They hit a server and then ask for the HTML and then construct a form based on that the user can submit. Many of the commands in kubectl are a similar pattern where a user supplies some set of flags to fill in some template, and then that gets sent to the API server. And so right now in the CLI experimental repo, there is a command which will allow users to publish on their CRDs as annotations arbitrary commands to kubectl with enough data to create a Cobra command with the description and help text and all this sort of stuff, and send requests and then format them in the response. I think that is the direction we are planning on going for the imperative commands. But if you have something particularly bespoke like exec or attach or these sorts of things that connect to the terminal and set up a TTY and that sort of stuff, a plugin is a good way to go for that.
And to also add a little bit color onto that is the effort that we have along with the SIG API machinery is that a lot of the functionality is being moved over the server, at least in the areas where we can. So for example, I mentioned earlier today server-side apply. So the end goal is that the actual apply logic that is currently hard-coded into kubectl will be moved over to the server, at least partially, so that other consumers, even in different languages, can reuse the same functionality. I also mentioned the server-side printing. So what is currently kubectl, if you invoke kubectl get and you get the description of pods or whatever resources that you have, this is provided by the server. And in case of CRDs have something that is called additional print columns, if I remember correctly. This is how you decide what will be those columns that will be printed aside from the creation timestamp and the name, which are printed by default. So you can tweak your CRD and the server knows what to return. And there is additional effort to do the same thing with describe so that the describe will be done on the server and not hard-coded in the client.
Yeah, I guess, and then the last piece is the way that scale is implemented is through a sub-resource.
Yes.
And that's how the client is able to discover it. If you don't know, a sub-resource is basically like a method on top of a resource. So it allows you to call that method for a particular resource. And so there is discussion now about what sub-resources make sense for CRDs, right? Because you could build them as webhooks, for instance, and allow arbitrary sub-resources to be published. You could allow a hard-coded set like scale and these sorts of things. So I think if you're building CRDs and then you say, oh, gee, it would be really great if I could implement this as a sub-resource, then that would be helpful information for the maintainers to know.
Okay, thank you very much. Please join us in our bi-weekly SIG calls or stop by our SIG channel. We'll be more than happy to help you with your contributions. Thank you.